So in the last video, I showed you how to use bus stop division. The numbers that I picked were important because they were actually related. What I'm going to do now is show you how to use the bus stop method when you end up with a decimal. There's two key words here before we start talking about decimals, which is factors and multiples. We got these keywords because 8 and 5,698 are factors of 45,584. That means that both of these numbers will fit exactly into this number. Whereas a multiple tells you that it's in the times table of another number. So for instance, if I carried on counting up in my 8 times table for a very long time, in fact for 5,698 times, then I would eventually reach this number. Same here. If I counted up in the 5,698 times table 8 times, I would again end up at this number. Now, what I'm going to do is show you a very similar sum. Here we've got 45,583. Now what we're going to do is work with 45,583, which is just one less. Now obviously, if this was in the 8 times table, one less definitely isn't going to be. So we're going to end up with a decimal. Now before I start this, I need to talk to you about the two different kinds of decimals. We have a recurring decimal, which looks a bit like this. Okay, or maybe this. Okay, we use these dots to show where the repeat stops and starts. So recurring essentially is just a shortened version of reoccurring, meaning it happens over and over and over again. This 0.6 recurring really looks like this number going on forever. I could carry on writing 0.666666666 until I die, and I will still never get to the end because it reoccurs. This one means that I have my reoccurring partway through the number or at the end. So this means that 1, 3 is repeated over and over again after the 7 occurs. Notice that this one just has 1 dot and this one has 2 dots. The first dot signifies your start of your recur, and your end dot, your second dot, tells you when it's finishing. This one though only has 1 because it's just one number that's recurring, so the start dot and the end dot are in the same place, so therefore you only see 1 dot because they're covering each other over. Now, the really interesting fact about recurring numbers, so you can always check your answer, is if you're dividing by any number that's not made by timesing 2 or 5, so for instance, if you divide by 3, 7, 9, 11, basically all of the odd numbers actually, you will end up with a recurring value. Whereas a terminating decimal is one that just stops. Remember, Arnold Schwarzenegger was the Terminator because he killed stuff, he stopped their lives. So terminating means to stop. So a terminating decimal is one like 0.75, it just ends, there's no repeat. This one, 0.3337. Now one thing you have to really watch out for when you do decimals on a calculator is sometimes they round at the very end, and it makes it look like it's a terminating decimal when it's not. So here is fine, but if I had 0.666, sometimes your calculator will round at the end and make it look like it does terminate. You have to be very careful and check your answer to see whether it's a surd, and I'm going to go into that later on. So, a terminating decimal will always be if you're dividing by a 2 or a 5, which is actually an odd number, so what I said earlier was a little bit wrong, and or a mixture of those two combined. So for instance, 2 times 5 equals 10, so if I divide by 10, then I know I'm going to get a terminating decimal. Whereas if I divided by 7, I know I'm going to get a recurring decimal, because you cannot make 7 by multiplying 2 or 5 in any way. So let's go back to the actual sum. So we're going to divide 45,583 by 8. The first thing I'm going to do is write down my 8 times table. So 8, 16, 24, 32, 40, 48, 56, 64, 72, 80. Okay, so how many 8s will go into 45? So let's have a look. Is 45 in the 8 times table? No, the closest number to it that's smaller than it. Okay, so the biggest number we can fit into 45 that's in the 8 times table is 40. So that's going to be 1, 2, 3, 4, 5 times. So that's, oh, sorry, my error. Okay. Now, we end up with a remainder of 5, which we have to deal with. Okay. How many 8s will fit into 55? Well, 56 is in the times table, but 55 isn't. So the closest number is going to be 48, which is 1, 2, 3, 4, 5, 6. So the 6, sorry, I should have crossed that one through. But we're going to have a remainder. So the difference between 55 and 48 is 7. So I'm going to put my 7 here and carry it forwards. 78. Is 78 in the 8 times table? No. 72 is, which means I've got a difference of 6. So we've got a remainder of 6, but 1, 2, 3, 4, 5, 6, 7, 8, 9 lots of 8 will fit in. And a remainder of 6. Okay. Is 63 in the times table? No. Now we've got a problem. Well, let's carry on the sum and then work out what to do with our remainder afterwards. 63 is close to 64, so 56 is going to be the closest multiple of 8 that fits in. So 1, 2, 3, 4, 5, 6, 7. But I've got a remainder of 7. Oh dear. At primary school, you probably stopped here. The only problem with that is, technically, the amount of 8 that will go into our number has a remainder of 7, and you should write 7 divided by 8, or 7/8. So we have 5,697 and 7/8. That doesn't seem like a very helpful number. Notice that I've written the remainder being divided by 8 to show anybody else that looks at it that I was dividing through by 8, and although I have a remainder of 7, it's still being divided by 8, it's still having an effect. What I'm going to do now is actually carry it on. So rather than writing as a decimal, rather than writing as a fraction, I'm going to write as a decimal. So what I'm going to do is put a decimal point in to show that I've finished working with my whole numbers, and now I'm going to create a decimal. So I'm just going to extend my line. First, I need to give that remainder somewhere to live. So I'm going to put a 0 here, and then I'm going to bring my remainder down and put 70 here. Okay. Now, straight away, I can look at this and check whether I'm expecting a recurring decimal or a terminating decimal. I need to check whether I can make 8 out of multiplying 5 or 2. So for instance, I know that 8 is 2 times 2 times 2. So that means that it's going to terminate because it's a multiple of 2. Okay. So now we just carry on the process. We've given our remainder a home on a 0, so now essentially we're working with 70. Does 70 fit? No. The closest one is 8. 1, 2, 3, 4, 5, 6, 7, 8 lots, which gives us 64. So we're going to end up with another remainder. So what's the difference between 64 and 70? It's 6. So again, I'm going to give it a 0 to live on. And now I'm going to work with 60. So 1, 2, 3, 4, 5, 6, 7. 56 will fit into it, but not, it's 60 is smaller than 64. So I'm going to have 7. And then I need to look at the difference between 56 and 60, which is 4. So I've got a remainder of 4 again. I need to give that remainder a home. So how many 8s will fit into 40? 1, 2, 3, 4, 5. Notice that it's stopped. It has terminated. So I now know that 45,583 divided by 8 is 5,697.875. Notice that you don't say 0.875. When you say a decimal out loud, you only state the digits.